Okay, so today we're working with something called compound inequalities. So the inequalities we've worked with so far are considered simple inequalities. So when there's one variable involved and one endpoint involved, we call it a simple inequality. It becomes a compound inequality when there's more than one simple inequality involved in it. Okay? So today we're going to work with the ones that are considered to be AND ones. In other words, we're going to find all of the solutions, all of the numbers that satisfy both parts. And meaning they have to both be, both parts of the solution set have to be working together. Okay, so there's a model up here. There's the first one that is given here. It is shown, and I would like you to circle this, okay? X is less than 5 and X is greater than 0. X is less than 5, so here we are. Here's our open circle at 5. So define that better with your pencil. Open circle at 5. It can't be 5 in that simple inequality. It has to be less than 5. So now let's just start shading going this way, but you don't need to go all the way yet. In other words, the numbers less than 5 are heading to the left. But not only that, we have to make sure that we include the X is greater than 0. 0 is not included, so it's an open circle. The equal to bar is not there. And we want the numbers bigger than 0, so they're going this way. So once we run into those other guys, we're like, okay, that's it. These are the ones that they share in common. Less than 5, greater than 0. Any number between 0 and 5 is to qualify as part of the shaded region, part of the solution set for this inequality. But here's how, put a box around this, here's how we will see that typically written. And we have to learn how to write them like that. So that's what we'll be practicing first here today. Here's how that reads. 0 is less than X and X is less than 5. That's how we read that statement. So we combine it together and X is in the middle. And notice our smaller endpoint is at the left end and our larger endpoint is at the right end. And 0 is smaller than all of these numbers in the shaded part. And the shaded part is smaller than 5. So that's how we kind of connect it together. Okay, so here's what we're going to do when we're given these, and we have to write them together like that, all in one statement with only one X involved in it. We have to learn how to write that properly. So if they give us this statement to start with, so what is that? Okay, well, which of those two endpoints is smaller, 10 or 4? Which of those two endpoints is smaller? We have 10 in this one and 4 in the other one. Which one's smaller? The 4. So the 4 is going to start out our compound inequality. It's going to be at this end, okay? And the 10 is going to be at the other end. Now, that's all we're going to do for a moment, because here's how we're going to decide how can we write it properly then. Since we need the 4 to be at the left end, we're going to take this inequality, that simple inequality, X is greater than 4, and we're going to flip it over. So the 4 is going to trade places with the X, and the sign is going to flip over. Did you notice on the key that I had an AKA? What does AKA stand for?
Also known as.
Also known as. So this is another way we can write X is greater than 4. We can write it 4 is less than X. So, and the other one, this one, we're going to rename it over here because we need the 10 to be on the right side like we have it over there. So we're going to have the X and the 10 trade places. And we're going to flip the sign over. So now, notice how it is written. X is less than 10. So now how could we write this with just one X involved in it? Well, this one starts out 4 is less than X, so we put an is less than sign there. The X is going to be in the middle. So there's one of our simple inequalities right there. 4 is less than x. And, but we don't write x again, and x is less than 10. And x is less than 10. So it helps sometimes to rename the simple inequalities. If you need to rename both of them, rename them both. If you only need to rename one, only rename one. Maybe you don't need to rename them at all. So does everybody see how this right here, put together with this one, kind of like imagine putting the x's on top of each other. Maybe if I wrote it off to the side over here, we could see it better. 4 is less than x. X is less than 10. So the x's just kind of land on top of each other, don't they? Okay, how would we graph that? Well, we got 2 endpoints to graph instead of just one. So we're going to put, we're going to put a circle at 4. Would we color that in or not? Is it included in the solution? No. So we don't shade it in then, do we? We put another endpoint at 10. Do we color that one in? No, because it's not included in the solution. The equal to bar is not there. And so remember this says 4 is less than x, x being the shaded part, and the shaded part is less than 10. So where are we going to shade? Where are we going to shade? Anybody know? We need numbers that satisfy being between 4 and 10, basically. So where are we going to shade? Really? You don't want to take a stab at that? Harley? To the left? To the left of what? Of 10, okay. Because x has to be less than 10, but x also has to be what? Has to be greater than 4. Remember it started out right here as is greater than 4. It has to be greater than 4. So the numbers greater than 4 head towards 10, and the numbers less than 10 head towards 4, don't they? So we shade in between the 2 endpoints. So in other words, any number we would pick from that shaded part would make both of those inequalities true. So somebody pick a number that's in the shaded part. Katie?
7.
7, okay. So if we pick 7, is 7 less than 10? Yes. Is 4 less than 7? It works. Okay. Anybody have questions? Let's do one more together, and then I'm going to see if you can do the next one by yourself. Number 2. Okay, x is less than 100, and x is greater than 50. Which endpoint is smaller? Which endpoint needs to be at the left end? 50. So here's our x is greater than 50. Is it on the left side? Is it on the left side right now? No, so we're going to rename it. We're going to flip it over. And 100 it needs to be at the right end, the bigger end. Do we need to flip it over? No, because right now it's at the right end, isn't it? So the 50 has to be at the beginning. The 100 has to be at the end, right end. So 50 is less than x. That's this one right here. 50 is less than x. And x is less than 100, but we don't write the x again, we just write the is less than 100. The x's are on top of each other. Okay, what kind of a graph would we have? Where would the endpoints be? Where are the endpoints at? Go ahead, Tyler. 50 and 100. Would either of them be colored in, shaded in? No, no equal to bars in either of them. Where would we shade? In between, yeah. First one says x is less than 100, the next one says x is greater than 50, so they are going to meet, and we only want the ones that make both of them happy. Not any of them on the other side. Questions? Okay, you show me your stuff, then you do number 3 all by yourself now. Okay, I have my compound inequality statement up there, that's what yours should look like. 118 is less than or equal to x, is less than or equal to 125. And tell me something about the endpoint 118. Should I color it in like I am? Why?
Because there's a line.
Because there's the equal to part, yeah. Should I color in 125? Yes, because of the equal to bar being there. It is part of the solution. And where else should I shade?
Between.
In between them, yeah. Are you starting to catch on that these and ones like this are in between the two endpoints? Now, here's how you can be certain, though, that you have it right. You would pick a number that is in that region, and you would see if it made both of them true. So, like 120. Is 125, I'll go back to the way it started. Is 125 greater than 120? Is 125 greater than 120? Yes. Is 118 less than 120? Yes. Okay. Okay. So, in the next one, do we need to rename either of the simple inequalities? Give their AKA. X is greater than 70 and x is less than or equal to 120. Do either of those need to be renamed? X is greater than 70 does, because we need the 70 where? On the left. So we're going to rename it as 70 is less than x. Do we need to rename the other one? X is less than or equal to 120? No, because the 120 that we need at the other end is already on the right. So we're going to take our first one that we have, that we renamed, 70 is less than x. We're going to combine it together with, so we're taking this one, our AKA name, and the other one, and combining them together. We do not need to write the x again, but we have to be really careful with our symbols, because notice one of the symbols this time has the equal to bar and the other one does not. That's important that we pay attention to that. So when we put our circle at 70, would we shade it in? No. When we put our circle at 120, would we shade it in? Yes, because it's the equal to part. And then we're going to shade in between them, aren't we? So I want you to notice something, though, that I don't want you to get just in the habit of thinking you're always just going to shade in between, as long as there's only one variable between endpoints. Tell me something that is the same in all 4 of these, besides the fact that they all have an X in the middle. What else can you say is the same in every single one of those compound inequalities? Danny? The signs go the same way, and that is which way? To the left. They are always is less than. They are always is less than. Both of them, aren't they? Is less than, is less than, is less than, is less than, is less than or equal to, is less than or equal to, is less than or equal to. Very important. If they are written like that, then we can say, then it's going to be shaded between the 2 endpoints. Okay? Okay, try that last one again on your own. See how you do. Try that one on your own. Again, very important, Carly, please stop that. Very important that we can tell it when the your circles are open and when they're shaded. We can tell what part of the number line is shaded. All of those things are important. So after you're done, check yourself out. Hopefully I have the right answer up here for you. Anybody who needs to challenge me on it can. Questions? Challenges? Do you have to do right? If you do not, and you're not going to challenge me, then you probably got need to get it changed. Okay, then let's move on to the back side. We are going to have to write a situation for the compound inequality that is given, and then we're also going to show it on a graph. But they're going to kind of determine the situation a little bit for us, because like in number 1 it says, the inequality is, so here's our inequality right here, let's circle that. The inequality is 125 is less than m, and m is less than 365, where m represents money in dollars. Let's underline that. M represents money in dollars. So in our situation that we write, we have to have this compound inequality represented with the M standing in for dollars, money in dollars. Now this is not how they want us to write it. 125 is less than money in dollars and is less than 365. No, they want a situation for this. So, anybody want to give it a try or want me to do the first one for us? Any offers? Wait.
I had a problem in my head, but I lost it.
You lost it, huh? Okay. Okay. Let me start us out then. The ticket prices for a concert Anybody think they can finish that for me? The ticket prices for a concert.
I'll go for $125 to $360.
Okay, now are 125 and 365 included? Will there be $125 ticket prices? Is there an equal to bar there? No. Will the 365 be included? No. So we have to be really careful about our wording. You're so close, Wade. We're going to say that the ticket prices for a concert are between $125 and $365. That does not include those guys. We just say are between, okay? The ticket prices for a concert are between $125 and $365. So now we would show that on a graph. Well, what would the ticket prices look like then? Well, 125, is that represented down here in the labeling? Oh, what's this? What is this number line going by? In other words, between labels, how many dollars are represented? Kaden?
10.
No, there's more than 10.
20.
It's going by $20 at a time. Well, that means we need to, first of all, we need to be, 125 would be here between 120 and 140, right? So halfway between them, what would that dollar amount be? It would be 130. Okay, I gotta do a better job. So this is 130. So now, where would 125 be? 100, halfway between 120 and 130. So now we're gonna have to put another mark right here, and let's just put below here that it's 125. Okay, I'm gonna erase my other little mark so that I don't have so much on there. You can do the same. So in other words, we have to have a good location for 125 on our number line. Are we going to put, we're going to put a circle there. Are we going to shade that in? No. Okay, now we have to do 365. Well, 365 is between 360 and 380, right? What's halfway between 360 and 380? 370. So this mark would be 370, right? Now we need 365. Where would that be? Harley? Halfway between 70 and 60. So here we are again. We're doing and getting rid of an extra mark that we do not need. Okay, so 365. Open circle at it. And would we shade it in? No. Is it included? No. The ticket prices are between those two. Any number in between there, but not those guys. Okay, so wording is really important in these, and when you're given the word statement already, you have to know what type of inequality symbol to use, and when to have that equal to part included, and when not to, okay? So, the next one, the inequality is, let's circle it again. The inequality is 5 is less than or equal to W, and W is less than 15, where W represents work hours. So our situation has to talk about somebody's hours at work. Anybody in here have a job? Okay, Harley, is it like an hourly job? You work by the hour?
Just work from like 7 till
So you're 7 till you're done, okay. Kaden?
I'm looking at that for the shop.
Okay, and you, like so many hours or anything?
Yeah.
Okay. So we're going to say, Caden, we're going to talk about him working last week. Caden worked at least 5 hours last week. At least meaning he could work 5 hours, right? Or what? At least means 5 hours or less or more. And that's what we need. We need it to be, because 5 is at the small end, so it goes from 5 to 15. So he worked at least 5 hours, but what? But did he work 15 hours, possibly? No, but he worked, but under 15 hours. So we can't include the 15 in whatever type of wording we use. So he worked at least 5 hours last week, but under 15 hours. So we know that he worked 5 hours all the way up to 15, but not 15. Okay, this graph is a little friendlier for us. We're going to do a circle at 5, shaded in. Okay, because he could have worked 5 hours. A circle at 15, shaded in. No, he worked under 15. 15 is not included, is it?
Oh,
Yeah, so sometimes one of them shaded and the other one isn't, just like on the front. So the shaded region shows all the possible amounts of hours Caden worked last week. Okay, you guys are coming up with the last one for me, totally. Okay, here we are. Here's our inequality statement right here. B represents the number of boys. My leg is straightened up, so I'm gonna put this back on. Help me out. Wait.
there are at least 25 boys in the arena, but under 45.
Okay, so he says there are at least 25 boys in the arena, but under 45. So then in other words, if it's under 45, would 45 be included? No, do we need 45 included?
Yes.
According to this, we need 45 included, don't we? Okay, so you're close. So I like your there as at least because the 25 does have the equal to, so it's going to be shaded in, so I like that. There are at least 25 boys in the arena, but I can't say under 45. You think of any other types of words that might work for this, Charlie? Well, up to means up to it, but not including it. You got something, Sylvia? At most, there you go. I think that's what Sylvia was going to say too. But at most, 45 boys. So at most includes the 45 then. So 45, but no higher than that. At most 45. And so the number of boys in the arena could be 25 or 45 or any number in between, right? Okay, questions at all on being able to write word statements or understand the word statements and how we set up compound inequalities? For now, anyway. No? Okay, then let's get out some loose leaf paper for homework.